Just please wait for some time. So let other people join. After that, we'll start today's session. Yeah, good evening. Anil. I hope you guys have done this week assignment 5. Today I will discuss a little bit about this. Whether it is online or not, I don't know exactly. Is it completed or it's going on still? It, week 5 assignment submission date is over. Anil, have you submitted this assignment? Nesra, please text it in this message box. Okay. Is it audible for you guys now? Yeah. So I was asking whether you completed this NSS week 5 assignment or not till now. It's live, I think. And what is the submission last date for this? Last date of submission?
30th.
Okay, then 30th. Okay. Thanks. If it will voice won't clear, then let me know. Okay. Okay. So uh, I'm saying on here one Google form. If you have any doubts you want to ask to a professor, then you can fill the Google form, like name and email address, and after that you can just go like you just type your question, and professor will join after next week. So maybe on just a second. Yeah, so he will join on 9th September, okay, if it is possible. And you can join that day and you can ask directly to professor as well. Any questions, any doubts regarding this course. And if you are feeling like, uh, is it my voice is audible? Yeah, so it will be at 9 September at 6 o'clock at same this time it's Saturday. Okay, so he will join and like you can ask directly one on one through professor also. Whatever questions, whatever doubts you have. Okay, so we'll move toward our today's assignment. What that is week five live session week five live session for week five. I think it is visible for you. The slides it is visible. Yeah. So I'll start from question number one of week five assignment. It's um, yeah. So question number one is a general optical fiber communication link as shown in below figure. Assume that a typical attenuation of the standard telecom fiber at 1550 nanometer operating wavelength is 0.2 decibel per kilometer. Okay, so let's say 0.5 decibel per kilometer. If we were to achieve the same amount of power at the receiver as transmitted power, then the gain of the each amplifier A should be decibel. Like what should be the gain? Assumes that both the amplifiers are identical. So here the signal is going from transmitter to receiver, and it is um, going through the optical fiber that is 100 kilometer long fiber, as you can see in the figure. And this attenuation is like of loss we can say that is 0.2 decibel per kilometer. So first, and they have given that amplifiers are having identical um, you can say identical it can amplify it. So this, okay. So first of all, we have to know that it's given attenuation is given for 1 kilometer. Okay. Okay. If you want to know about 100 kilometer, what we have to do? At loss, we have to calculate like with alpha. Loss will be this. this Loss will be alpha into n. So alpha is over this the rate according to that loss is happening 0.2 decimal per kilometer, and this length is 100 kilometers. It's already given in image. So our total loss in the fiber will be. Uh, can you just tell me a little? Is it audible? Am I audible? Yeah. Now I think it will be audible. So here, how much it will be? Can you just tell me?
So I didn't get that last question.
Did you got this?
20 due.
Yeah. Total loss is 20 days. So each amplifier should be how much amplified. So we can recover that loss. Two amplifiers is there. So one amplifier and this ripple should be amplified. So that's the question was. Now we'll go for question number two. Question number two treatment is like in a three-level atomic system, the small signal inversion is N naught. As the flux density of incoming signal photon increases, the inversion value also increases. So, is it a true or false? Can you tell me?
Sure, sir. I think it's true.
So, it's given that in three-level system, small signal inversion is N naught, and the flux density of incoming photon increases. So, flux density of incoming photon increases, then inversion value also increases. It is like why you are telling it will be increases the inversion value. See here, you can see properly that flux density of incoming signal photon increases. The inversion value will be, I don't think so. It will be increase. Are you agree with my point or not?
Yes.
Like you can just think about this, whether it is increasing or decreasing. The inversion value should be increases or decreasing.
I think it should decrease level.
First, yeah, you should first see that question properly. Sometimes it will just confuse. Okay, so the question is made according to that. You just click on, you can just click on the wrong answer. That's why. Okay, it's a quite simple question. The statement is wrong. Yeah. Yes. Increases and decreases, that is only matters here. Okay. So they'll go through it again once. So you can follow lecture number 20 if you want to know exactly. The syllabus system is there. Okay, now question number 3 will go. So which of the following is a classic example of four-level atomic system? So can you tell me? It's Dubru Charan is also there. Um, have you solved this assignment? Okay, like this network issue is there. I can't do anything much more than that. Why is it breaking? I know that. Like, did we solve this?
No, sir.
Okay. So this is week 5 assignment I'm solving here. Whether you have any doubt or
Maybe
not,
the second or the third one.
uh,
I think it's the third one, sir.
third one, like four level systems. Can you go through once this lectures and just let me know? Lecture number 21, you can go for like four level atomic systems. I think your answer is not correct. You have to go to like lectures first. I can't do too much about this things. This is a concept-based thing. So any solving things is not there. Like, I can't solve anything from the problem here. So go through this lecture number 21 for this. Memory based question only. Okay. So lecture 21 is always. Okay, question number 4 will go now. This is simple. Just a second. Okay, so question is the saturation plus density for a medium is exacted lifetime of 1 microsecond and the emission cross section of 10 to the power minus 25 meters square has a value of um, like we have to fill in the blanks. We have this the unit is per meter square per second, and the value should be in a like it's given in a like 10 to the power 9 also you can write, or either e to the power e9 also you can write. Okay, that's example given that. So the question is quite simple. It's given that excited state license. And sigma e. If you just do like saturation plus density, give me some time, 5 minutes. Unbelievable. Very class related. There is competition. Hey, sorry, I'm watching the answer one. Okay, so here we have solved this question number 4. You can follow for this. Yes. Is it okay to you? It's quite simple um, problem. Okay, now question number 5. Saying that an atomic system corresponding to equilibrium dome fiber amplifier is shown in below figure. If it is operating at 915 nanometer form and 1064 nanometer signal wavelength, then the atomic system is referred to as. Can you guys tell me what could be the answer for this? Right. Okay. Guys, can you tell me like what could be the answer here? Have you studied about this 3 level, 4 level advanced systems like
Also, I have to start.
during YouTube? Like what could be the answer? Like ABCD you can see. Did you did you solve this question? Yeah, okay, fourth one. Cannot see. No, actually it's like why you are telling it's you can't say this one. Like you can see properly here, like how this labels are there. Okay, fourth one. Okay, fourth level. Okay, okay. Yeah, so you are correct here. Right. According to this labels is there, now vibration levels. The excited labels. So here this this so we have this not very specific. So this whatever the pump pumping, you go to this excited state. It will this metastable state will be very shortly. And here also this state it will be and this one will be long and this here softly the state. So based on that, you can say that there will be four level, quasi four level system. Okay. If you want to learn more than four level system in the lecture 21, you can go and you can see that. Okay.
Yes, sir.
Lecture 22. Yeah. Okay. Now this next question. A question and reasons. So here, the assumption is ground state depletion is a condition that corresponds to most of the atoms in excited state. And reason is given the a relatively large number of formed photons results in saturation of the game. So, okay, okay, it's changed. Reason changed here. Like I was seeing in the previous assignment. So reason is given here like gain will get saturated. Okay. Okay. So, what could be the answer for this? According to you guys, assumption and reason, because it's live. So, whether you should also answer sometimes. Okay. So, what's your opinion about this? Anirudh, Dhubru, Dhubru Charan?
Maybe both are true, but the reasons
And correctly,
may not be the correct response.
no correct. Okay. Okay. So, you're telling this both are. So option A, B, what should be? Here I'm confused. You are telling both are correct and not a correct explanation. Huh? Is it your option option A you are telling or B you are telling? Not sure. Okay. See here both are correct only. Like both are correct also, and the reason is correct explanation for assertion. Why? You know that while we are exciting, we think we have two levels. One is ground state and another is excited state. So while we are pumping, so everything is going in excited level. Atoms are going to excited level. And we have so many excited atoms. Then what is happening? So this ground state depletion is happening here. And the reason is saying that a relatively large number of photons result in saturation of the gain. So large number of photons gets it is obviously saturated gain the um, uh, after that if it is in excited state, it can't be more pumped. Like you can say that saturated there. It can't go down also, it can't go up any other level. It's like the level is like if it is an active state, so more and more numbers will photons will atoms will be there, and you will not get like space to fulfill again. So based on that, this reason is also correct, and assumption is also correct, and the correct explanation. The reason is correct explanation of assertion. Okay, you got my point. The reason why it is correct explanation for assertion.
Yes, sir.
See here, like for photon resistance saturation of the gain. So most of the atoms will be in an excited state. So ideally will be more power, like more from photons. Then it will be in saturation state. It won't go to ground state or either like another level is not there. We can say that it's correct region. Okay. If you want to like follow this, you can go for lecture 20. Okay. Now this question number 7. So here, so for a typical free level atomic system, the graph between inversion and not versus pump rate R is shown in below figure. Where the following regions marked. So here is like graph is between the inversion, this side, and this side is pump rate. So first it is in A region. So can you just match the columns? Like it's quite easy. If you see that A, so what could be the like perfect match in column B? Just type if it is. Yeah. Hello, Kritika. Uh, so guys, please let me know which option will be correct for this A. In column A, the reason is A. So in description, what could be the description according to you? Anirudh, please let me know what do you think about this. Have you followed this
Not
lecture?
sure about reason.
Yeah, which one you are telling? Like the
Not,
option?
not sure.
You
It's
should
the
tell it's like you could have followed this question lecture. That is very easy to understand. Okay, so it's in lecture 21, lecture number 21. So what is happening here? First, the negative inversion is due to more ion sitting in the ground state compared to the excited state for small component. So here what is happening? It's a negative inversion we can see. So here in this region what is happening? Absorption is happening. See, like first if we have to see about this like material, whatever the system we are using, here three level atomic system is there. In that, before applying any bias, okay, or before like it's optical pump. So maybe either we can say optical or electrical. So if it is like optically pumping, so first whatever um, gain medium will be there, that will just absorb the photons it won't it won't emit whatever absorb and emit. Okay, so just absorb, then we can say that in this region all things are absorbing. No, nothing is transparent. Okay, 100% absorption. Then what is happening at B? This will just tell that level where that um, pump rate and like what we can say and not will be zero, equal to zero at that certain particular pump rate. Okay, where ground state atom equal to excited state atoms. Okay, so it's like a level, like excited and ground atomic levels will be equally filled. So in A, what is happening? If we are talking about A, so many atoms are in ground state. Okay, and if you are talking about this B, what is happening? Suppose there are four atoms are there, then here two and here, like this it is happening. Then what is happening at like C in that region? Here the transparency is occurring. Okay, not transparent. Now what is happening? If you're talking about C,
Gain.
yes. So more number of atoms will be in the excited state. Then what is happening in D? You can see clearly what is happening. Ground state depression. This is the last option. No? So everything is gone to the excite ground state. It's nothing is there. Like most of the thing is in excited state. Most of the atom is in excited state. So saturation happens. Okay. So almost nothing is there in ground state. We can't say almost nothing, but yeah, like ground state depression is happening. So saturation occurs here. Okay. So after that, we can't feel more there. So that's why this slope is, you can see this V is sticky now with N naught. Okay. While we are pumping more, like pump rate is more, we are increasing pump rate, then nothing is happening to this inversion and zero. Okay. So like that, you have to do this questions. Like that. This is quite easy question. First of all, you should know that A, what could be A, because in that reason, that inversion is not at all possible. So you can see that absorption is the best option for that. Then B, what is happening? It is a steady, what we can say, like it's more like ground state and excited state both are feel equally. Okay. Then in C region, what is happening? This inversion started positively. So we'll see that we can see that the excited state having more atoms compared to the ground state. And in the last, saturation happened, and most of the atoms are in a excited state. And after that, whatever we are pumping, there is no change with this inversion. And not. Okay, so it's very interesting question. Okay, now question number 8. So which of the following economic system requires minimum from power to achieve population inversion? Can you guys tell us what could be the answer for this? It's quite an easy question. If you follow the lecture, then you can
O level,
score
sir.
oh, you know that's the problem with two-level system. Like what is happening, whatever we are exciting, um, what we can say here, we have more number of atomic, like more levels in atomic system. That will be quite easy to pump the and to get the population involved. You should know this because two-level system is quite hard. It is okay, but in IR region you can get and microwave region you can get easily with two-level atomic systems. But if you are going to this visible region or ultraviolet region, it's very difficult with that. Okay, so the just follow this lecture number 21. You'll get to know that level like two level, three level, and two level atomic systems, and what would be the proper answer. Because you are not studying for this assignment, you are studying for your knowledge. So you just go through this, so you get to know like how to according to these questions, you can get to know like what would be the proper answer. And just give you hint here. We have more number of level system, more level number of levels in atomic system, then it will be having minimum pump power. So it will just excite and it will just throttle you in that particular state and it will come to the long lived state and there will it will emit. So it is the cycle is very quite easy. You should know that um, CO2 laser is there and helium neon laser is there. So helium neon laser there will be like it will go to the excited state and it will transfer the energy to the another gas atom and there gas atom is excited state and from there it will emit to the ground state. So it is like a like four transition circle. Okay. So first it is exciting with some pump photon that is going to excited state and energy transfer is happening to the another atom gas atoms to excited state and then it is emitting to the ground state and coming to the ground state and then after that again it is that photon again exciting from this like uh, excited state to ground state to excited state. So in CO2 it is quite difficult where you have the atomic levels less atomic levels system. Okay, so just go through this. Question number 21. Now this question number. Okay, so for question number 9 and 10, this common instruction is given. So consider a glass cell filled with a gas as shown in figure having absorption line at 635 nanometer. Let the laser at the same wavelength and a power of 10 milliwatt is incident on a gas cell and the power measured at the output of the glass cell is 67 microwatt. Assume that the internal loss of the glass cell is negligible. So here, first of all, we have given the instruction that we have to assume that um, this internal loss should be negligible. Okay. So the question number 9 is that you can see here that the length of this cylinder, that glass cell is 50 centimeter. And question number 9, they have asked that the energy of the photon which is absorbed in the glass cell is in autojoule, they have asked. So what could be the answer for this? How we can solve this? Just let me know first, you guys. Like what could be the proper way to solve this one? See what is happening here. I'm audible, guys. Just tell me yes, no, please.
Yes, sir.
Okay. So in this, what is happening? First, the gas is there, and the 50 centimeter glass cell, and it will absorb at a particular, here I can see. So it absorption is like 635. Okay, particular this thing, it will absorb. Okay, either I can say like this in level, it will be level of this is. So it is absorbing a particular 635 nanometer. And that wavelength, whatever we are giving, that is 10 millimeter. So I discussed about this phenomena in the previous question. There it was like concrete and that inversion. Okay. So in this region, what is happening? First of all, it will just absorb. So whatever light you will give, whatever the photon you will give, that will just absorb. This one we saw this one. Okay. Okay. So here, after the absorption, only the output is coming 67. So okay. Suppose we are attacking with this 635, and power stands milliwatt. And here, what we are getting after this absorption and everything? Internal loss, we are assuming that 0. So we are getting 67 microwatt. It's quite very less compared to this what we are giving. Okay. So, so first of all, we have given the lambda 635, and we know that energy and lambda relationship. What is the relation between the energies? This energy, so, we have to, yeah. So E is equal to H is equal to H lambda. Oh, just a second. Yeah, sure. So, yes, and yeah, this setting from this side, because you have another, and maybe what coming this side 6794, and as we know that whatever the wavelength is coming from this side also, it will come. Okay, because it is absorbed in whatever the leftover is left, that will come this side. So the lambda will be 6 35 nanometers. Then energy remote and see my data, and as we go like 1250 divided by 35. Then so you can get this. Yeah, so here we can get. Now it is visible on screen. I just say it again. Okay, here I did one mistake. Um, when there is it visible for you guys?
Yes, sir, it's visible.
So yeah, this value will come in what? Unit you have to convert it in joule. It will come in electron volt. You have to convert into joule. Okay, so it will come in after joule. You can convert this units. Okay, okay. If you can solve this now, then I can just let you know if it is correct or not. Can you guys solve this question? Just convert the unit. That's it. Do you want to do now? Like, what do you want to do? Okay, you just try this. So the question, the last question of this assignment is this. The question number 10. It's asking about the number density of a gas ion present in a glass cell if the absorption cross section of a gas is 0.5 into 10 to the power minus 28 meters square would be a meter to the power like it's in a per meter cube. It's asking. Assume that all the gas ions are in the ground state. So again, it is given like you can give an answer in a into 10 to the power minus 10 to the power 9 something like e9 also you can give. Okay. So First of all, we know that what is the power input we are using. So power input, 10 milliwatt. Can I ask one general question, guys? Have you seen any laser till now? Laser diode?
Yes, sir,
Yes,
you
sir,
have
you have
seen.
seen. Yeah. So 10 milliwatt we are giving, and we are giving like we output 67 microwatt. That is quite less. Okay. And uh, so absorption cross section is also given. Sigma. Here we can see here it is by the circuit like this. This one. Okay, this value absorption cross section. So what could be the relation there? Power output is given as like this. So E out is equal to P in. Okay. E to the power. I'll just write here better. Minus alpha E Z. Okay. This is the relation between this P output and P input. So alpha P, how we can calculate? Directly related to the N sigma E. Okay. So and Z, what is Z? Z is equal to D. That whatever the length. So what is the length that is given in the case this glass length? Okay. The same things we have to keep here. Now what we can modify this. So just remove this P out we know. Just now I get here. So um, okay. So P out is okay. P out is 60. Whatever is coming outside. So 10 from resistance is equal to P in. P in was 10 microwatt. So 10 to the power minus. We can say minus. We are converting it to watt. Everything. And into the side is into minus n. We know that what is the value of the sigma is this value 0.5 into 10 into the z value is given in centimeter, so we have to convert it to meter. It's in so after solving this one, you get the n value, and that will be in meter per meter cube or meter per minus 3. Okay. You got it this how to solve it? 0.03. Okay, question number 9 here. Yeah, almost. Just check again. Something you did wrong here. Can you just cross check this question number 9's answer? It's not correct. Anirudh, are you there? Am I audible, guys? Okay, so here we have completed the questions. If you want to solve this question, I can wait for that. Just solve and let me know what would be the answer. So we'll just um, conclude this. 0.6 so
Solving.
um, please use the scientific if this question's answer in easy. I think it is also not correct. We can check again. Another guy Aniket is there and Guru is there. Guru Jagan. Can you guys follow me? So we can discuss this question. You can use math solver also. It is not an issue. Yeah, almost you were there, but it's not 10 to the power 27, it's 10 to the power 29. Just recheck this answer. Maybe you are doing something wrong there. Maybe you are forgetting this. Convert into units.
I took centimeter.
Didn't get you? Like,
The distance was
yeah, so it is centimeter, 50 centimeter.
yes.
Convert into meter first.
Yes, I didn't do it.
Yeah. Okay. Then question number 9 you did wrong. Can you check once again? I think you are doing something calculation error. It's really not a big mistake, but because of this you will get marks according to that only.
Oh, okay.
Electron volt you have to convert to joule. So what you have to multiply with this?
1.6.
Yeah, 1.609 into 10 to the power minus 19. So it will become in joule. Okay. Your answer is 0.0312. Actually, it's a 0.313. I think not 10 extra zero you have given after this decimal. That is not correct actually. You can just check it. Okay. So I just sent you this Google Forms. If you have any doubts, you can ask directly. Professor will join at like Saturday, 9 September at 6 o'clock. So you can directly ask him also. Yeah, that's correct. Answer is correct. Okay, guys, if you have any doubts, you can ask me directly, or you can fill the form and it will go to super like it will go to the professor. Okay, just a second. Just give me a second. I'll just change the settings. Now you try, guys. Is it okay? It is not easy. Yeah, now it will be possible. I think. So I will just remove that question number 5. Okay. Just ask me what is your doubt there. Yeah. Let me know. What is the doubt regarding it? Maybe it will work now. Okay. So pattern I should like answer is given for me it is 44 level. you have doubt, then I can just go to it and I'll just send you in the next uh, class. That will be better. So our next class will be on exactly solid me. Or you can ask, or you can ask in Google Form. So I just replied within 2 days. The Google Form I gave. Okay, second of September. I'll be online. Otherwise, you can ask in Google Forms. Whatever the doubts you have for next week, also you can ask in Google Forms. So I can try to solve this maybe this week itself. Okay. So whoever joined in this course, just go through this whatever the doubts they have. So better to ask in a form so I can um, solve that doubts before itself. So we have a good discussion in the like during our live sessions. Yeah. So better I should stop here. The last whatever was you have like this Google. Thank you so much, guys, for joining.